Okay, good morning girls. This is question number 5, one of exercise 1E. Okay, and the question is, categorize each of the following as rational or irrational number. If they are rational of the form A upon B, what can you say about the prime factorization of B? Okay, so before we come to this problem, I'll just remind you that about those rational numbers which we have talked before. Rational numbers. Okay, suppose it is denoted by in the form A upon B. And we know that there are two types of rational number according to the decimal expansion, and that is one type is when the decimal expansion is terminating, and the other one is non-terminating. But okay, non-terminating, but they will be either repeating or recurring. Okay, and if a rational number is in such a way that B is of this form 2 to the power m into 5 to the power n, then we remember that this has a decimal expansion which is terminating. But if the decimal expansion of that rational number is non-terminating but repeating or recurring, then B cannot be of that form. B cannot be written in the form 2 to the power m into 5 to the power n. Okay, so when I say terminating, that means you understand it is something like this. Okay, 3.754. Yeah, okay, example like that. When I say non-terminating or repeating, then that means you understand that it is something like this, 7.333. This is repeating. Okay, that means 3 is repeating. If we have like this 7.312, 312, 312, that means here 312 is recurring. Okay, so we say that it is either repeat. They do not end. That means they are non-terminating. Okay, but they are repeating or recurring. Okay, so when 3 digits are repeating like this, that means we say recurring. So we write bar on top of those digits, 312. Here also, instead of writing, keep on writing like that, we can write bar upon 3. It means that 3 is repeating. But we have another type of number, and that number is called as irrational number. Irrational number. What is irrational number? An irrational number is a number which is non-terminating, and also it is non-repeating or non-recurring. Okay, that means an irrational number is non-terminating and non-repeating. Okay, non-repeating or non-recurring. Okay, so this rational number, that means for example pi is a rational number, 22 upon 7. If you divide 22 by 7, okay, then you will get something like 3.14 and so on and so forth, and you will realize, okay, you will, and just for your information, that these decimals after the digit, okay, on this pi, they will never end. Okay, scientists have been doing experiment on this, okay, even using supercomputers, and they have seen that even after trillion places, imagine just 1000 places also, but after trillion places also, these digits do not end. Okay, so that's the amazing fact about this. Okay, so here in question number 5, we just have to categorize whether they are rational numbers of this form, or of this form. That means irrational number. Okay, categorize each of the following as rational number or irrational number. As rational number or irrational number. If they are rational number, then we have to say whether they are of, then the denominator is of this form or not. It is of this form if they are terminating. It is B cannot be of this form if the rational number has a decimal expansion which is non-terminating. But if we have a decimal expansion which is non-terminating, non-repeating, then we say that it is an irrational number. For example, in question number 1 is 14.2312345. It stops here. So that means this is a rational number, okay, and the denominator, that means b, can be written in this form, because the question says if they are rational number of the form a upon b, what can you say about the prime factorization of b? So if they are rational number, then you have to say what the form of b, whether it is like can be written of this form or cannot be written of that form. Okay, if they are irrational number, then you just have to write irrational number. So what about this? This is a rational number, okay, and the decimal expansion is terminating, so it is of this type. So you say that b is of the form to the power m into 5 to the power n. What about number 2? What about number 2? Number 2, as you can see, it is like this: 5 2. 5 2 is 3.1212121001210000121. Okay, so as you can see, these numbers, they are not repeating. Okay, they are not repeating. Yes, 0 comes here, it also comes in this, okay, and then again it appears here, but it's not repeating. Okay, it's not repeating or non-recurring. So we have that means they appear randomly, and also we see that these digits, they do not end. So that means it is an irrational number. Why? Because it is non-terminating and non-repeating or non-recurring. Is that clear? So this is, you just write it is an irrational number. Okay, so you keep doing like this for the other types of for the other questions also, and you can even do this for question number 8 also. Okay. So therefore, you write down the solution this way: since the decimal expansion is terminating, therefore it is a rational number and b is of that form. Similarly, for question number 2, since the decimal expansion is non-terminating, non-repeating, and non-recurring, therefore it is a rational number. It is an irrational number. It is an irrational number.